So in this piece, what we'll focus on is what instructors get out of introducing open-ended, rich problems in their courses. And the main thing that instructors get out of doing this is that they get access to student thinking and student ideas, and so they can adapt their instruction accordingly. So this is a really important piece. And so in this section, what we'll do is we'll hear from some colleagues of mine who will talk a little bit about practically bringing these kinds of things into the classroom. And because drawing out student ideas and talking with students can actually be an important skill to develop, we'll hear from a first-time TA about her experience trying to develop some of these skills of learning how to listen to students and draw out their ideas.
Well, if I'm going to make decisions in the classroom about my effectiveness as an instructor, and I want to adapt instruction accordingly, I need to be open to questions that are going to generate a range of responses. So I want more of a window into student reasoning. So I could choose to either control the discussion by asking questions that have more yes or no answers or correct or incorrect answers. But that's gonna check more of a surface level of knowledge and understanding. So I want to open up that space a little bit more, because then my instruction is more student-centered, is more consistent with students' ideas. If I don't have any opportunity to elicit those ideas as part of instruction, then my instruction is possibly going one way and students are just trying to catch up or follow along.
When we ask more open-ended questions, I think this can be a little bit scary for us as instructors, because it's hard to know, how is this going to go? How are we going to get students to a place of understanding? When I'm working with first-time instructors, the sentiment I hear a lot is, I just can't let them leave class with the wrong answer today. And, and so I think it's important to back up a little, look at the time scale of learning, that sometimes it can take longer than a single class, but it's hard, we want students to get it.
Part of that process of actively constructing understanding and building a kind of durable understanding of the world sometimes will mean you have wrong ideas. There's ideally a temporary moment when someone's ideas are inaccurate. But what we find as well is this idea of wrong ideas is often more complicated than we might think. So a student might articulate an idea that sounds wrong. It may be the wrong answer from a kind of at the end, but actually the underlying logic is absolutely right. They might have been working from a different set of assumptions and reasoning from those assumptions in a way that was logical and sound. So on one hand, I would question the idea that it may not be actually a wrong answer that we're hearing, or it may sound like a wrong answer, but once we get a sense to understand, once we ask and listen and learn about how that person is constructing their understanding, there's a logic to it, and that betrays a certain kind of deep understanding. Now, we might also learn in talking to someone about their ideas, whether about evolution or in the process of natural selection, for example, that they actually do have the wrong idea. They don't understand that concept properly. But from a constructivist vantage point, we would see value in that learner having a chance to articulate their ideas, try to explain their reasoning. In the act of explaining their reasoning, they might realize that it doesn't hold up. If you had a course session where students are discussing ideas and there seems to be an inaccurate idea about natural selection floating around the room, that might trouble you. And certainly you'd want to come back to that and call attention to it. But the alternative, which many people jump to, is a kind of easy, quick fix that doesn't actually solve the problem. So what's the alternative? The alternative would be to explain what natural selection is and give the proper definition, ask people to write notes on it, ask them to memorize it, and then re-articulate that a few weeks later. It doesn't mean they've actually learned the concept. We have a lot of cognitive science research that would support that what I'm saying, that they may be capable of reproducing the statement or reproducing a definition. Doesn't mean they could then apply that concept to a new domain or be prepared to sort of handle new kinds of data and apply that concept in a deep way.
I asked some of my colleagues whether they had any tips for practically doing this in the classroom.
One of the tips that I have is to use a small set of talk moves. Talk moves are really powerful tools to help you refrain from saying good, right, wrong, or would somebody else like to try? So one talk move is to simply ask students, say more. when you're confused about their ideas. Get them to explain their reasoning. Or ask another student to say, who thinks they understand what so-and-so just said in their own words? Can they explain it to the class? That particular move is really powerful because it helps you to build a culture of reasoning in the classroom that is a lot like the science community, where we argue together. We try to understand each other as a community and figure out what kind of knowledge or claims can be supported by evidence.
Yeah, quick tips for listening to student ideas. The first one I would say is hold back your first impulse to make an evaluative statement about the quality of the idea. And if at first it sounds like it's a wrong idea, ask for a bit more explanation or ask the student to say more. Almost invariably, you'll find out they know more than you thought they did when you get at the logic underlying what the statement was. So the tip is to be patient, check your first impulse, I think, and really be inquisitive as a teacher.
So Ben has this really nice point of being patient and inquisitive as an instructor, but sometimes it can be really hard to be patient, and drawing out student ideas can be difficult as well.